Hello, everybody. Welcome back to the Engineering Entrepreneur Podcast. This is Scott Tarcy. Still having this voice issue, but getting surgery in a few months, so we'll get that fixed when we get to it. I run, this is episode 142 of the Engineering Entrepreneur Podcast, and as I'm sure you know, I run CADdesignhelp.com. Please go to that website and sign up on the email list, and then we'll send you a free PDF, and you will keep updated on all the latest podcasts that way. And I always ask for reviews on iTunes or whatever podcast app you're using. And if you have any feedback, you can send me an email at info@CADdesignhelp.com. So I guess this week is Jessie Frazelle, and she's the co-founder and CEO of KittyCAD, which is a new type of CAD, which should be interesting because that's obviously directly related to what I do. So, Jessie, thanks for coming on. Let's just do some background first before we jump into that.
Yeah, thanks for having me. Excited to be here. Yeah, I can tell you a little bit about myself. So for about 10 years, I worked as a software engineer on like infrastructure projects. So considering most of your audience is a bunch of hardware people, they might not know about Docker, but it's this tool for like deploying things on infrastructure and like making it really easy. So I worked on that, and then I worked on at Google and Microsoft also on infrastructure things. And then myself and two other co-founders started a hardware company where we built rack scale servers. And so that was my first like entry into doing hardware. And so I figured, because in the software world, like whenever a software engineer needs something, they just build it themselves, like whether it's, an automation or whatever. And so I was like, oh, there must be like really cool hardware tools. And to be fair, there are really cool hardware tools that are hardware. We had a bunch of like our hardware folks internally build these little boards and stuff for like connecting things and stuff like that. But the software for hardware is really behind the times. As a software engineer myself, it was like insulting to use the CAD programs that exist today because they're just crazy slow. You can't do workflows where you would automate things on them. Kind of like if someone changes something, you would expect that you would automatically run simulations and then know if it failed without even having to talk to another person and stuff like that. And so that's kind of where the idea for KittyCAD came about, is that I was just really confused with the status quo, and I talked to my co-founders about it, and then finally we were like, we should start our own company to make this better.
So a couple of questions. So why did you go from doing what you called it infrastructure? Well, I guess what is that exactly? Software infrastructure.
Yeah. So when you deploy a software application, there's a bunch of things that go into it. And so I was working on all the tools to make that like as simple and easy as possible. And then run it across like multiple servers, make sure it fails over well, make sure like your website stays up. Those were all of the kinds of things that I was working on.
Let's do an example of that. So like, let's say Google, you said you worked at Google, right? So like Google, what is it? Sheets where it's, or is whatever the Google's version of Excel is. Is that kind of an example? Like you need to make sure that works on the Chrome browser. You need to make sure it works on the Safari browser, that kind of stuff.
It's actually a bit different than that, but this is a good kind of entry into it. Okay, so when they deploy Google Sheets, it gets deployed to this thing called Borg internally at Google, which is a bunch of these software processes that run on their like millions of servers, and then they spread out across the globe so that it's fast for everyone. And so when a change is made to the Sheets code base, automatically, once it's approved, it deploys across all this infrastructure, all these servers. And so that piece was what I worked on.
Oh, so that's how you got into the server thing, because you were working directly on these servers yourself.
Yeah.
So why start your own server company? Was it just there was a need in the market for another one?
Yeah, so Google, Microsoft, even Dropbox, Uber, they all make their own, like they host their own servers internally. They don't use the cloud. And it's because of the scale that they're at. It's just not economical. Like AWS, all of them, you get these huge bandwidth bills. Like bandwidth is actually like the heart of it, that is so expensive. And it just doesn't make sense. It's like renting a house versus owning one. And then like if you go to run on-prem versus in the cloud, your options are Supermicro, Dell, and then you need this whole software layer on top to do what I was explaining before. Like you want to automatically deploy your applications, it gets served across the globe, and like everything works out well. And there's a few different companies that do that software layer, but they're all crappy, and then they all have to work well on all these types of hardware, whether it's like the SSD drives that individual like Dell server is using, or the memory cards and stuff like that. And so things are constantly failing. The firmware is, I mean, I don't know if you've heard stories, but like Intel was shipping for a long time a HTTP server in their firmware, which like, why would you ever need to connect to the network from the firmware? That's absolutely horrifying from a security standpoint. And so we decided to do what like Google and Microsoft do internally, which is make their own hardware. They don't go to Supermicro, they don't go to Dell, they make it themselves and they write their own software on top. And so we were doing that for everyone else who was stuck with like kind of duct taping together these like Dell Supermicro things and then some software on top.
Okay, interesting. So you need to do some CAD to actually create like the physical. I mean, I've seen server racks, like it's just kind of like a metal shelf, right, that holds the computers.
Yeah, I mean, we made ours aesthetically pleasing. So if you go to our website, oxide.computer, it's like we were trying to be like the Apple of server racks, you know? And so it looks really nice. And that's kind of like where it came into play, is that we had industrial designers that would want to like change the aesthetics of the rack and add like holes in certain areas. And then it would take weeks to run the simulation to see if like the rack was going to explode because of that.
Like explode, you mean because like the weight of it or something like that?
Because of the heat.
Oh, the heat of it. Oh, okay. Yeah, because the simulation stuff is kind of like pretty complicated in terms, like from an engineering standpoint. There's a lot of variables and a pretty high end expensive like package just to get that.
Yeah, I mean, and like ANSYS is great. Like KittyCAD isn't even taking on the problems of ANSYS, but the thing that I wanted, which like exists in the software world. So like in the software world, if I make a change to a code base, automatically a bunch of tests are run. And I know without having to talk to any of my colleagues, without having to annoy anyone, I know whether it can be merged, like whether like it should be accepted to the main code base because these tests are running. But in the CAD world, it's like, hey, here's these changes to this file that I made. Then like someone else has to go run the simulation. Like there's no automatic hooks for just doing this on every single change.
No, not really. Fact, I'm sure you're familiar with SolidWorks at this point, right? Because you've been doing some CAD work.
Yeah, totally.
It's like once you finish it there, it's getting better, but like you really have to do like SolidWorks doesn't really do a lot. Simulation's very limited, so like you'd have to re-export like step files. I'm assuming at least step files or STL files for ANSYS to do its part, and it's just very cumbersome to go back and forth like this.
Yes. So that's like exactly the problem. Also, SolidWorks, I don't know about you, but SolidWorks simulations are complete trash, in my opinion.
I haven't done a lot of simulation. I've used it, and it seemed to be okay, but I was doing more of like deformation simulation, not heat, which is, I guess, obviously that's the biggest issue for you because right with servers, there's a lot of heat being generated in these computers. That's why they have these massive warehouses with a huge air conditioning bill to keep everything cold.
Yeah, totally.
Am I right? Okay. So I guess let's get into like KittyCAD. So you told us why you started it. Tell us more about how it works. I don't know. We can compare. Like I downloaded it. I went to your website. I downloaded it, but I have not actually installed and opened it yet. So I have not messed with it out of this moment. But I am going to take a look at it later.
Nice. Yeah, I would love your feedback. So we launched this alpha. So like I just want to be clear that it's an alpha. So like there's bugs and it doesn't have all the features of obviously like a SolidWorks or, NX or something like that. But we're going to get there, and then it won't be an alpha anymore eventually. But so we launched a modeling app, which like the abbreviation is KCMA, but it stands for KittyCAD modeling app. And so it's kind of a unique take on a CAD app because it has the very traditional feel of a CAD application, in that you can click and point and create all the kind of, 2D objects you want, and then extrude them into 3D and stuff like that. You can do it all through the GUI and click and point, but also on the left-hand side of the application, it is generating a scripting language code. And the nice thing about this is, if you wanted to just write code, you could also just write code. But the nice thing is then when it comes to like changing parameters, like you would in like parametric CAD and stuff like that, you can just change the code, and you can do a bunch of like math in various ways that doesn't have to live in like an outside spreadsheet in the code itself. And so it's kind of like true parametric CAD in that regard. And like other things like this exist, of course, like if you look at the code CADs, like there's OpenSCAD, there's a bunch of different ones, but they don't have the aspect that we have where it's hybrid. Like you can click and point and it generates the code, or you can just write code itself.
Yeah, I mean, I know SolidWorks has the ability to write macros, which is, I guess, similar to what you're doing. Like, if I'm doing the same process over and over, I can write a macro that's going to automate this for me, but it's not very easy to do. I've tried it, sort of had some success, but at the end of the day, it's just easier for me to just point and click is what I found. But tell me more about how your system works, and maybe you'll convert me over.
Yeah, I think macros are kind of an entirely different thing in that like you can't build an entire project in macros purely. I mean, maybe that would be absolutely absurd, but it would need to be Turing complete, and I highly doubt the SolidWorks macros are Turing complete, but I'd love to be surprised because that would be nuts. But basically, like you can take this scripting language file, and then that is a reproducible model. So you could convert it to a step file, you can convert it to like a GLTF or like whatever you want to use, your SDL to send to your manufacturer. But that is a reproducible artifact in that macros are not.
Oh, right. So what I mean by the macro is more of like the modeling tree, right? So when you create a model, let's just like, looking at my desk here, it's like, okay, I have a cup. So I'm gonna sketch a cross section, then I'm gonna do a revolve, then I'm gonna I'm gonna go sketch the top plane or whatever top surface of the cup to make a lid. And like you have these series of steps, right? And then when you export that to a step file, it's removing all that. It's just the data. So what's important in CAD is that you have this history so that you can make changes easily.
Totally. And so like, I think that eventually we would have the concept of macros from the click and point of view, and that it would then be generating a function on the code side that is like continually doing this kind of same thing over and over again. Because that's kind of like one-to-one what a function is like.
Right. So, if I had this cup and it's 5 millimeter diameter and I changed it to 4, depending on how I constrained things and built things later, like the lid of the cup, if I change it to a smaller cup, the lid's going to shrink to fit with it. Like if you design it in a smart way, I'm assuming like your guys' program is going to work similar, but you have access to the code. I'm trying to understand I get the benefit at a high level, but I'm trying to break it down to like examples to get a better understanding.
Yeah, totally. I actually have a good one. Okay, so one thing we've heard from people, and I'm like wondering if you've also had this pain point, is that like you create your model and then you like kind of the last step that most people tend to do is like fillet all the things that need to be filleted. And then like something will happen and they need to change something like somewhere else in the model, like resize it or something like that. And then their fillets all get messed up. And with code, because we would have filleted based on a tag versus on a surface or edge or stuff like that, we would have actually tagged things to be filleted. It would re-fillet all the things that needed to be filleted without having to like go through and do it manually.
Okay, I get it now. So I'll explain more of what happened. So I'm very familiar with this problem. And the reason that fillets fail is because let's say you reduce the size of something, right, to where the fillet is now too large to fit. That's why it'll fail. Now, if you had a model where it's a box, like 5x5 box, very simple, right, and you put like a 1 inch fillet on every edge, if you shrink it down to 4x4, it's still going to work. Now, if you shrink it down to under 1x1 with a 1 inch fillet, it can't fit that, right? So now all those are going to fail. You could write it, and this is where the code part comes in. You can basically have it as an equation. Say, okay,
Yeah.
the design intent is that the fillet is 1/5 of the edge distance, right? So now it's always 1/5. I think there's a way in SolidWorks. Actually, I'm almost positive. This is like where you use equations, and I do this sometimes. Where I'm like, if I know that this, no matter what I change this box to, that it needs to be 1/5, I'll use an equation in the first place. So I'll give a variable name to the box with height with it's a box. It's a square box, so it's all the same. I'll say it's X. Well, in the fillet area, I'll put equals X divided by 5. It seems to me like you're doing a similar thing here, but maybe I'm wrong. So go ahead.
Yes, totally. So, 100% what you're talking about, where like you could make the fillets like a percentage of a number, or like actually calculate it out so that when the box got super small, it would fix the fillet size, basically.
Okay, so it seems to be similar to that. The difference being how you do it, because like I said, in SolidWorks, there you can do this. It's all based on how you set it up in the first place, using a variable or an equation versus using just a hard number.
Right.
Okay, cool. Um, so I guess tell us more about it. I'm not sure you know it. I've got a very high level understanding of KittyCAD now. I need to mess around with it to understand it better, but give us some more things you guys are working on.
Yeah, so the other nice thing, like what I was talking about, where like I would expect if someone else on the team changed a file that we could automatically run like in the same kind of software workflow, the simulations on it. So if you push your code to a Git repository, which is pretty standard in the software world, you can set up actions to run on it, and then you can call out to ANSYS or whatever and run your simulations on the export file, or you can convert the file to a PNG, so you can just easily look at side by side like what changed in the file. We actually launched at the same time as the editor a CAD diff file viewer, so that you can actually see the differences between two files when people change them visually versus having to look at the underlying like step file things that changed, which is absolutely absurd. So there's a bunch of things that you can then run with because you have all the tools at your disposal for doing things on file changes, basically.
Yeah, because like currently you would have to actually open the CAD to see it, right? Like you can, if it's
Yeah.
automatically generating images, and I'm assuming images from different angles, so you can kind of see it like automatic. Like you write it in such a way it says, okay, automatically generate me the top view, side view, right view, front view, isometric view, whatever. These 5 to 10 images because you got to. It's a 3D object. You got to be able to see it from multiple sides to compare. But yeah, that should be something that could be more or less automated. Whereas right now, there's you literally have to have the CAD program open it and open up the old one and like put it side by side. And you can't do it from your phone. Like you could do with this kind of workflow that you have. You could do it from like any kind of web application. Really, you wouldn't actually have to have the software installed on your device just to see
Totally.
images.
Totally.
It sounds similar to what um, I believe it's Onshape is the cloud-based CAD. Is that right? Have you looked at them? Because they're in some ways what they're doing is similar because they're hosting all of the CAD background in the cloud in their server, so that you don't have to download a program onto a device. Any device can do it, even a phone. Although it's kind of limited because without a mouse, it's trying to trick you to navigate.
Right. But the difference is, I mean, like we also run in the cloud, but the difference is, okay, like if I want to automatically have step files generated every time I make changes to like this file, and then I want to automatically send them to the industrial designers, or I want to automatically send them to my manufacturer so that they can like approve them. You can automate these workflows like that with code. And I guess like the other thing is like Onshape doesn't have code really built in. They have feature scripts, but you can't kind of do the same hybrid type of workflow like we have with feature script.
Okay. So what are some examples of, I guess, working directly in the code? And like what platform is it built on, C or like JavaScript? Like what kind of code do you need to know to do this? Because I'm not a computer, like I've done a little bit of coding in my life, but like I'm not an expert at that, like as I am in like being a industrial designer and mechanical engineer and like knowing, like I know how to use the program I know how to use, right? I could always learn new things, but where my expertise is knowing how things work and like how to design stuff.
Yeah, totally. So we're trying to make it very approachable for mechanical engineers. And so we have a mechanical engineer on our team, Josh, who's like freaking amazing because he keeps, us software people humble and make sure that we aren't going too far down a bad path that like mechanical engineers would not understand. And he's actually gotten really good at the code, but it's not traditional programming language at all. We wrote our own so that it would be really straightforward. Hopefully when you try it out, you'll kind of see it's really hard to describe, but it is kind of just like CAD commands, like you call extrude on something, or you draw lines. It's very primitive, I guess.
All right, let's build like verbally on the call like this. Let's build some type of object. Let's make like a box with a cylinder on top, like kind of like almost like Thor's hammer, if you will. You know what I mean? That's basically what it's hammer. It's like it's a handle with a block. Let's build that. Tell me how that works I mean, I know how to do it in the graphic side. Like, we've already talked about it. How would I build that with code? I'm just going to type this out. Give me the commands to do this. And you can pick the dimensions. It's probably like 1-inch diameter cylinder by 5 inches long with, a 6x4x3 block on top.
Okay, so I mean, it depends where you want to start. We can start with the block, but let's say you're just clicking in the GUI. If you click and create a rectangle, it will generate code for like start, and then it will have the start point that you clicked at. Then it will have a line, and then it will have another line, and then we'll have another line, like a square. It can also call close.
Yeah, good. Sorry, I had a question, but I'll let you continue.
Okay. And then after you close this thing, which I assume like if you're just clicking, like you automatically click to close it, then you extrude it. So you go from 2D to 3D. So extrude would be the function that is generated. So that's just a box.
So if you were typing it out, you would type out, well, in SolidWorks, like I always come back to that because that's what I use most of the time, but like you have to pick a plane to start with because you have something to sketch on.
Yeah, you choose the plane. So it's like start sketch on is the function. And then in parentheses,
okay,
like XY or YZ or, whatever it is, XZ or a custom plane, whatever plane you want,
Yeah, okay, I get it. So yeah, you guys have created your own, your literally your own programming language to do this.
Yeah. And then for the cylinder, we have functions like arc. So you could create like a 0 to 360 arc, which would be a circle, and then extrude that.
Now, I'm wondering how you're going to handle like the really complex stuff, like surfaces and like kind of like really weird organic shapes. Like, I mean, that's going to be a challenge, I think.
Yeah, I mean, so CAD has been around for a long time, like OpenSCAD and a bunch of others do it, CAD query. So like they have proven that it can be done to like the highest level of degrees. It's just no one uses it because mechanical engineers aren't going to write code. Also, like, as a software engineer myself, you can't actually picture something in 3D and then like just code it up. Like I could never do that. I don't think anyone could. It's hard enough to do 2D on the web. I mean, like 3D is a whole different level. So I think that you really need to be able to also, I don't think anyone's just going to sit here and like type in code CAD, right? Like you're going to draw it yourself, you're going to click it yourself, and then you're going to go in and tweak it in the code. And so that's kind of our approach to it.
So give me an example of where, okay, we built this thing. You just told us how you built this, like, we'll call it the Thor's hammer. That's kind of what I'm visualizing. Now, why would I go into the code to change it? And like, how would I do that? Like, why would that be easier than using the graphic interface like you typically would in other programs?
Well, so I mean, like, what's the purpose of your part, right? Like most parts are actually like they're holding something, they need to withstand some sort of force or pressure. And so in order to do that, and they're made of certain materials. And so to be able to actually calculate and build something that could withstand a force, you would do that in code and then kind of plug those variables into your model to make it, you know, the width that it needs to be or the thickness that it needs to be able to withstand it.
Okay, so you're actually putting in variables then, and then
Yeah.
that way you can change. Okay, I see what you're saying. So it's similar to like the SolidWorks, kind of using the equations like I was talking about earlier.
Yeah.
All right, cool. I'm not sure what else to ask then. I feel like I got a pretty good understanding and you've given a good number of examples. Is there more things you want to tell us about, like what's coming up and where you guys are going with the like? Is like you have a whole business around this?
Yeah, so I mean our goals are because you'll use the app and you'll see that it's very limited in the actual like CAD functionality that there is. And so like our goals are to get all the CAD primitives there, like revolve and you know, binary operations like subtract. We have like cut, like a way to cut the holes all the way through and stuff like that. But there's a bunch of things missing basically. And so we want to get all the CAD primitives in, and then we'll call it 1.0. There's a bunch of other things that we're working on as far as like using AI models to generate CAD. Like nobody does this well today because they're all generating like 3D meshes, which you really need to generate VREPs for it. So yeah, I mean, the other thing is like once we get to 1.0, it'll be really interesting to do benchmarks on using our CAD engine versus using something like SolidWorks because we rebuilt our CAD engine from the ground up to really leverage the GPU, not just for rendering, but for actually doing mathematical operations. And so like I know at my previous company, it took like an hour to open our CAD file, which is just like absurd to me. Like, especially for the hardware that exists today. I mean, like all the previous CAD kernels are all built for the hardware that existed 30 years ago. And so there should be some significant performance improvements and we'll run a bunch of benchmarks on them when we have a lot more complex features to really show.
Interesting. Yeah, I never heard of an hour to open something. I've had a few files take me like 5 minutes or something, but never an hour. That's pretty wild.
Yeah. I mean, most companies like I know SpaceX, Blue Origin, like almost every single big hardware company actually has a person on staff that is there to help people make the CAD models faster, which is nuts.
That's really crazy. Yeah. The companies I worked at did not have that. Now they did have a guy whose only job was to manage, I guess we called it like the database, right? So it was like these were controlled documents, like the CAD. Like when I worked at like Bosch, where we had like dishwashers, there was one guy whose job was like to manage the database of all the parts because you couldn't have like somebody getting in there and changing stuff and like what's the latest revision, and like that was like a full-time job just to manage the files.
Yeah, that's nuts.
So as far as the business then, it sounds like you guys are just it's kind of all open source now. You're not charging anything. How are you going to turn this into a business later?
Well, like one, no one's going to pay us for what we have so far because, like I said, it's missing a lot of like the CAD primitives. But once we get to 1.0, and especially if we like show off how much faster it is, definitely people are interested. And the other thing is like so many modern CAD companies today like have software engineers on staff to help kind of automate these pipelines for the hardware folks. And so this is really like a huge gateway into doing that a lot faster because then instead of having to have like version control everywhere, everyone just uses Git. Everyone, you can push your models up to Git. You can actually have human readable differences and also the visual diff of the models themselves. And then you can, once simulation pass, you can automatically merge them in. You can be sure that when things change, you know, you aren't breaking anything. And then also you can do like calculations on things as well. So like when automatically, you know, like make sure before merging something into like the main code base that the mass didn't get higher than some threshold of the model and stuff like that.
Yeah, it sounds pretty powerful. Kind of curious. I'm kind of keeping an eye on where you guys go with this. How long have you guys been working on this for?
So at the beginning of this year, we hired a bunch more folks. So we've been working for a while, but it wasn't until the beginning of this year that we had like 5 new members of the team to really hit the ground running. And so that like significantly helped us get further along the line. But like I said, like I like want you to be aware when you try it because I do really want your feedback that like you're gonna be like, oh, there's no fillet function yet. And it's like, yeah, we're aware. Like we're very close on that, but also we're aware that it's missing.
Yeah, and I'd like to hear how like people like fund these things. Did you get some venture capital for this?
Yeah, we did. And thankfully we were able to because hopefully like I just can't imagine that we are still using the same CAD programs in 10 years from now that run on the hardware from 30 years ago. You know, it's kind of nuts to me.
Yeah, well, I think that's where Onshape is really pushing it because that is totally different. Like what they're doing, like it's not like it's kind of crazy to me that like even like 5 years ago, you had to literally get a CD mailed to you to like install the latest program. I mean, now you can download it like from the SolidWorks side. Um, but yeah, I mean, it seems super outdated. Um,
Yeah, but
but
Onshape really only runs like on the web. Like I don't even think it's leveraging the web GPUs. Like I think that it's cool that it runs on the web. I mean, honestly, from like a security standpoint, I'm sure there's a bunch of folks that actually just don't want it to run on the web or they want it to run on their own cloud or whatever. Like their private cloud. I just like the web doesn't, to me, the web doesn't make it different other than the fact like you said you don't have to like get mailed a CD or whatever but like it's not making it faster, it's not making the experience better, it's just like cool, now I can load it in a browser, I guess.
yeah, I mean, it gives you more like you don't have to have a certain computer to do it. Like it definitely makes things easier because I have SolidWorks installed on my computer and I had to buy a very expensive computer with a very high-end graphic processor just to like load these models. But if I was using their stuff, I really wouldn't need to because it's all based on their computers doing it.
Yeah, I mean the thing is like that actually shocked me is so when I first used SolidWorks, I was running on a Mac and I use a VM. And I was like, oh, this is why it's slow. And then I got out my gaming rig with like the latest, NVIDIA card and stuff like that. It didn't make it faster because these CAD kernels themselves are single threaded. Like, sure, if you set it up correctly, you can render on the GPU, which if you look at Reddit, like there's so many memes about people setting even that up wrong. But it's the actual math that is slow as well and needs to be done single threaded in some places, but it could be sped up in others. And that's where I think we're like really differentiating.
Oh, okay, so you guys are actually calculating things like the math side in a different way.
Yeah, there's like a few different ways we're doing it, and like also hoping that once we do fillets that it will be very different, but I don't want to like promise it, but there might be something in the works that is very fast for fillets.
It sounds like some of this might be patentable. Have you guys tried to
Yeah,
get
yeah,
some
yeah.
patents
That's
on these
definitely
processes?
We're working on that as well for the things that are, but still like in the exploratory phase. We need to make sure that this is actually going to work.
Yeah, because you're right. Because I remember talking with my friends, Rick, about this. We were like, it's kind of amazing that SolidWorks even works. Like, it's literally doing math and some of the most complex shapes imaginable. Like, it's calculating every single little point. Like, how is this even possible? I can't even wrap my head around. Like, yeah, I'm not talking simple stuff. I'm talking like, they literally drop an entire vehicle in CAD with all the thousands of parts and all these, the body of a vehicle is very organic and flowing, and it's not just a box. And somehow the program can load all of this. And I mean, you need a very powerful computer, to do that because there's like thousands of pieces in there.
Yeah, it's actually nuts because like a lot of people like compare it to like animation and stuff like that. And I actually feel like it's pretty different because animation, you aren't creating a physical good because it's like you still, like you were saying, like it has to calculate all this, it has to render it, but then it has to be real. Like it has to be so precise that when you go to manufacture it, you get the thing that fits.
Right. It's not an image. Like that's what people like I explain to people. It's like when you create a CAD file, you're not creating a picture. You're creating the actual thing. Yes, from from a user standpoint, like it looks like an image because there's no other way. You can't like otherwise you would just see code and a whole bunch of math. That's not the case. But it's truly incredible. Like what these computers can do with this stuff.
Yeah, it's absolutely insane. And I think I underestimated just how hard it was until we got into it. But it's hard in a way that like the software engineers that work with us like love, which is good. But it is also it is so crazy hard, so much harder than just meshes, just because it has to be a real physical good.
Yeah, and that's where like a program like Blender is literally it's just triangles in space. So that's better for organic stuff because it doesn't need another map. It's just like, here's the point, but you can't edit this in any easy way because it's not parametric, right? It's just, it's a dumb model.
Yeah, totally.
Yeah. And I find it hard to model those programs because I'm a numbers guy. Like I need to know what is this distance, right? Like I'm not good at this type of modeling, like the Blender and the what is the other one that people use all the time? It's like for like characters like Unity, and there's a couple other ones.
Yeah.
Maya, yeah.
It's so different because, and that's actually something I learned from the solutions engineer on our team is just because he cares so much about like the actual numbers, which is why we wanted to give him the code to calculate exactly precisely what he needed. And he actually like loves it now. But like that's kind of like why we went that direction because it super matters. Whereas with like Blender, like you were saying, like you create this like kind of image that looks nice at a certain scale, but it doesn't matter what scale it's actually at.
Right. It's just it is a 3D model, but it's very limited 3D model. I did want to ask a few more questions about the whole venture capital and getting funding. Can you take us through the process? Because a lot of people, they want to get their project or their ideas funded, and they just don't even know where to get started or how to do it. So maybe tell us your story there.
I will say I'm like not the best at fundraising, but luckily, like for me, my co-founder Jordan, who's been on your show, is very good at fundraising. And so that's why I'm very glad to have him as a co-founder. But yeah, it's hard. I mean, honestly, it's hard because unless like the VC really gets and believes in what you're doing, they're not going to fund it. It's also like it's a weird process because there are a lot of VCs that fund pure software, but then especially with my past company that was doing hardware, there aren't a lot that do hardware because it's a lot of capital up front and the margins just aren't as good. These are all the excuses they make and blah, blah, blah. Even though I feel like most hardware companies, if you pull it off, it's bound to make a bunch of money just because then it's there, as long as there was obviously a need for it. And so it's really about finding the right partners for you and the VCs that really get what you're doing. But it is extremely hard, and there are a bunch of VCs that are just like not as technical to get a lot of these things that people want to do. Sorry, that wasn't like good advice, I guess. It was just the reality.
Okay, so you weren't really involved as much in the funding side because I'm just kind of curious the venture capital company or person that you're using and and like how the go and stuff like that. But if you're involved, we don't have to worry about
I mean, I was involved in like, a lot of the calls when they were serious. But yeah, it's a lot of like talking to a bunch of folks, seeing if they're interested, trying to sell them on your idea, like over and over again until you find the right partners for you, which I'm glad that we found. We found very, very, very good VCs, and I am glad of that. But it is a very long and arduous process to get there.
Yeah, and did you have to show them like an initial, you call it the alpha version to kind of like get it? It's like, "Oh, here's what we've done so far," like to get them like kind of like the prototype, right?
Yeah, we definitely show them progress along the way. I will say like it feels easier to show people your ideas when you do have something built, even if it's super early, because at least they can kind of see where you're going without just having to do like these arm waving things, with nothing. But yeah, I mean, when you're like seed stage, like when we originally raised, we didn't have much other than an idea and like a pitch deck, and so it's harder.
Yeah, because I mean, like, a lot of inventors and stuff, they want to like maybe license their product or get investment. And like that's kind of what they need, that initial CAD file or even better, a prototype to show in a meeting versus just, like maybe a sale. Like you could always do an artist rendering and a sales sheet, but I think that's a lot less powerful than having something, in your hand, depending on obviously what it is. If it's something small, you can 3D print. If it's, some kind of massive machine, then you might have to just do like a sales sheet on it. But I think something physical is always better.
Totally, totally.
All right, cool. Well, let's get towards wrapping up. My second to last question is, what is your number one tip? So we talked about a lot of things. What's your number one tip out there? Could be for engineers, could be for CAD, could be for business.
My number one tip, is that it? Sorry.
Yeah.
I don't know. I guess do what makes you happy. Because I personally like love like engineering things and putting things together and like seeing if they work and then fixing bugs and like going through that. And so like I actually like love that part of my job. And so find something that makes you happy and do it. That's my tip.
Good advice. And then lastly, people want to get in contact with you. What's the best way?
You can go to our website, kittycad.io, join our Discord. There's a link at the bottom, and then there's some cool people in there talking about hardware design.
Oh, and I did want to ask, how did you pick the name KittyCAD?
Oh, so that wasn't me. That was my co-founders. But yeah, it's a pun. And there's like this whole story, which they would tell better than me, which involved, I think, one of their grandpas who said it, but something like that.
Okay, well, then we'll get back. You can get back to us on the answer there. 'Cause, sounds like it's an inside joke a little bit.
Totally.
All right, Jessie. Well, thoroughly enjoyed the conversation. Thanks for coming on the show, and we'll catch everyone next time on the podcast.
Okay, cool.